Share. Okay, and the microphone is running on the right microphone. Life is good. Okay. Oh, good. Here comes some people. Okay, that's a good sign. So let me turn down the, whoops, not that, but the sound. There, I got rid of the sound. That should help. All right, so good. There are a couple of people here. All right. So this is CNIT 129S, and we're going through this book, which is the Bible of this business. Let me see if I can do anything about this junk getting in the way. That should theoretically fade away after a while. All right, so this is the Web Applications Hackers Handbook. This is the Bible of people who do vulnerability bug bounties. And people from NCC came and visited, and they said, we had to teach this book, and they're hiring people who've been through this book. In fact, if you want a job with them, and I have 2 students that got a job with them in the last month, they have a CTF you have to prove that you know enough to get hired, which I think is pretty awesome. So anyway, this is the Bible, and it turns out that the reasons why the web is very pretty simple, and nothing has changed in 20 years. This book was originally, I think, written 10 years ago, and not changed all that much in the update as far as I can tell, and yet it's all in there. Every time somebody has a new web hack, it turned out it's already in this book. So we're going to go through quite a bit of this book. This book is written by the guy who made Burp, and it basically is teaching you how to use Burp. Burp is what you use to find web application vulnerabilities and exploit them. So we're going to go through how the web works. The main thing about the web is there are a ridiculous number of servers and languages involved. A typical web developer knows 30 languages. It is stupid, it is mind-boggling, and it's why the web is so vulnerable. This is like you had a staff, and your staff has people that speak only Japanese and only Arabic and only Etruscan, and they talk to each other with imperfect translators to get everything done. So no wonder it's a security disaster, but that's how it's really done. And every new product that comes out has to write its own stupid language, and they all look just like JavaScript anyway, but somehow everybody has to write a new language for everything. So if I was in charge, I would tell them to knock it off and just use Python for practically everything, or else JavaScript, but unfortunately, people fail to ask me before doing this stuff. So anyway, that's the book. There's an online system to take quizzes. You can just click this link and enroll. It is not the City College Canvas, so don't bother contacting the help desk here to get in. You will not be able to get in. I'm using my own Canvas instance so I can have the advanced features that they don't let us have here. So you join up here, you can take quizzes on there. The only thing on Canvas is quizzes and your grades. All the rest of the projects are on this page, and they're down here as usual. And most of these you train by sending an email. I haven't bothered to integrate them all with Canvas, and when I have new projects, I'll probably add that. Anyway, yeah. I don't know, but this is where I really am. It got moved. This is CNIT 129S, which is Web Application Exploitation.
Oh, I think you're supposed to be teaching securing network.
And this is securing web apps. Yeah, securing web applications. Yeah. Okay, let me write it on the board if I can find it. Okay, why don't you tell me from down here? I don't know where they were going. Thank you. 129S. All right. Securing web applications. All right. I was afraid that would happen, but they were so efficient at changing the room that I no longer had a record of the old room. Anyway. All right. So as far as the grading goes, it's the usual stuff. There's points for quizzes and points for homework, and there's a final exam, and 90%'s an A and 80%'s a B, and so on. So here's the grading policy. Probably nothing else worth mentioning here. Yep. All right. And the usual stuff. If people are like committing cyber crimes or something, I reserve the right to kicking you out of the class. That'll be the least of your problems. But anyway. All right. All right. So I think I'm just going to start with the first couple of chapters here. And there are some paper versions of the first day handouts up there if anybody wants them, but I don't expect those to be big sellers. All right. That's our fine. Yeah, good. I'm glad you made it. Okay. So let's go here. Yes. Here, there we go. All right. So, As the web applications are these programs running on servers that take input from the user and then process it and pass it around, typically to databases and such. And the fundamental problem with all of this is that the users can supply arbitrary input in things like credit card numbers and usernames and passwords. And at a more deep level, every web application is 6 or 8 servers running different software, sending signals to each other. And unfortunately, almost every one of them accepts essentially unstructured input from the others. So there are many other places than you might imagine where you can inject something that is misunderstood by the next person in line. And the most classic example is SQL injection, which has persisted for 15 years with no improvement because it's not anybody's fault. This is what happens a lot. You have one guy running the database, which is running as intended, another guy running Python or PHP, which is running as intended, and neither of them feel like it's their job to fix SQL injection because their product is working. When they pass it off to the next product, it's misunderstood, but the next server will say, I'm doing what you told me to do. And the first guy will say, I sent you the right command. And so everything falls in the cracks. And this is true of almost all web application vulnerabilities. There are people that only understand one system and secure that one system, and they don't generally feel responsible for making sure that the inputs they get from other systems are not misinterpreted, or that the outputs they put out are not misinterpreted by the next system in line. This is sort of like government, like City College and, for example, Congress, where a bunch of people do what they want and they feel like it's not their fault the whole system doesn't work. They say, I did my job. It's not my fault that the other people don't do their job. Like right now, the Republicans and the Democrats explaining how it's somebody else's fault that the government doesn't work. This can persist forever. And it has persisted since the dawn of the web, and it is very hard to fix. And this is why I've actually been moving more and more into defense, more and more into management, because management, in my opinion, is the problem. And that's why I'm going to teach a class next semester for managers, and I'm trying to integrate more with the business department because I think managers are the only people that can fix this. Managers are supposed to be the people who see the big picture and say, look, the whole company is failing. I don't care that you think you're brilliant because your product is running. The big structure is not working. And we need somebody looking at the big picture and seeing, do all these components actually accomplish getting the job done or not? And that's upper management. But anyway, so static, the old web 1.0, you just put up a page and people will just look at it. This was simple and relatively secure. There's not that much to go wrong there. But the modern web apps are very complicated. Things like Wikipedia and Amazon, every viewer is different. You dynamically generate the content, people are logging in, and people are even putting things up there, like Facebook and Twitter. You're taking input from the users, putting it up and serving it to other users, which is really dangerous because users can put up something that hurts someone else, and now you got a problem. And of course, to be fair, the big problem is not technical. The big problem, which is really bringing us to our knees right now, is social engineering. The huge problem is Twitter and Facebook are being used to put up malicious comments which insult other people by insulting their ethnicity or manipulating elections and stuff. And that's not a technical problem exactly, but it is the problem. And it amounts to the same general problem that you have taken input from a user that your staff did not write, and then you've delivered it to other users. And Facebook and Twitter have tried to say, we're not responsible for that content. And the US government is increasingly saying you are responsible for that content. And now Facebook and Twitter are hiring censors to censor the internet just like China. And the people in government in China must be laughing. They say, you Americans pretend to have free speech, but you've ended up exactly where we are, trying to censor the politics off the internet because you can't stand the chaos it causes. So you can just get off your high horse and quit pretending that your free speech is working out better than our rigid internet control. But anyway, that's where we're at. So many things are up there: auctions, gambling, shopping, email, all on the web, and all these have the same problem. You take a lot of input from one user and you pass it off to other users. And if you don't really understand exactly how to sanitize it, it can do harm. And now people are putting everything in the cloud. Me too, of course. I don't have servers running in my house. I have cloud servers for my web page and all the projects and everything. So is everybody else is putting their employee payroll in the cloud and their customer relationship management in the cloud, and everything else is all running in the cloud on other people's servers, because it turns out to be very much better than trying to run all these things locally and paying your own staff and backup and power and cooling. But it means you're trusting all these other people to handle your data, and it is extremely obvious that they're not very careful with it and they lose it right and left. Anyway, web apps are awesome. HTTP is designed to be fast. It is connectionless. It's very easy to serve a lot of people over HTTP. The problem is it did not have any facility for sessions or identity management, and all those things were bolted on afterwards in a imperfect way and turns out to have a lot of problems. So as you know, breaches are happening all the time, and a lot of people have responded to this by lying. So they put up things saying this site is secure because Semantic says it's secure. These things are hilarious. Most of these make it easier to hack the site. There's a whole genre of hackers that figure out how to hack a site because of this. Because you can watch this test, and you can watch when it changes and know when the developers put up a vulnerable version of something and made it have a hole. You know, it turns out to be not a really wise idea to publish your scorecard automatically. And here's one of the ones I got involved in. I tried to make a blockchain voting system. I made it, we're talking more in 141 about it, the cryptography class. I put up a blockchain voting system before the last election, and I made it, so I put up a prototype, and I got a lot of votes, and Trump won. So I took it down and said, well, this thing is obviously garbage. But it turned out that was right. Not that I had enough votes to matter. But anyway, at the same time, other people are trying to sell it. And these guys put up this thing and said it's 100% secure. So I contacted them, and I said, please don't say that. Never say anything. There's no such thing as 100% security. This does not happen on Earth. And if you say that, all you're doing is advertising that you're an idiot. So I sent them a more polite version of that. I said, do you actually have any security staff?
Probably not. It's just something between you guys.
Still claiming this. But if you claim to be unhackable, the hackers of the world will just take that as a challenge, and you'll be sorry. This has happened over and over again. So here's the textbook authors checking how many things have serious security vulnerabilities. 90% are cross-site request forgery, cross-site scripting, SQL injection, broken authentication, and so on. Yeah.
Remember when Steve Jobs got up and said how secure that was, and then like within a week or two, they had thousands of attacks.
I did not remember him doing that, but I know a lot of other people have done the same thing. Yeah. I mean, nobody is perfect. We should know this from the physical world. I mean, how do you know that somebody that hates you won't shoot you while you're walking down the street? The answer is you don't know. The president isn't safe. The Pentagon isn't safe. You know, you're fooling yourself. There is no perfect safety anywhere at any level. All there is an acceptable level of risk, but the risk can never be brought to zero. So you have to do threat modeling and say, what are the things that are likely to happen and which ones of them can I reasonably stop, and then accept that. You cannot have perfect security at any level. So here's I think a game company called SynVR, and guys had a web API that would let anybody download the customer database. This happens very often. So they found a way to send an unauthenticated request because the authentication system was broken at the server. You could send a request which was interpreted as having management rights, but it didn't. And down you get all the personal identifiable information of their users. This happens over and over and over again in various ways, and we're going to talk more about it. We'll be going through the OWASP top 10 for web apps, and here's the mobile apps, but they're very much similar. Things like weak server-side control, insecure storage, broken cryptography, and injection attacks. These are useful categories of the vulnerabilities, and most web apps have several of these, and it is important to understand them and how to clean them up. I tested a lot of Android apps, and they're all vulnerable to code modification and all kinds of things like insecure logins, and we'll be doing this in the mobile device hacking class, which is also happening this semester. We'll be auditing a lot of Android apps and seeing what they've done wrong. When I first taught this class, I used an Android app written by a security company to train on, but ever since then, we've used real apps from companies because people write garbage and they never patch it. So I give them 30 days to patch it and then become homework. And I just wrote a bunch of those today. They're all using apps that haven't been patched since 2017. People just don't care. But now they're being humiliated. TD Ameritrade had some ridiculous flaws in their app, and I noticed they finally did patch it, so you can't keep seeing that flaw anymore. So at some point, after 2 or 3 years of humiliation, they actually do patch things, or maybe it's just their staff changes.
Wells Fargo is number one because they stole that money.
Well, that's true. Wells Fargo had another problem, but their app security was not at all the worst. Anyway, but they also had other problems, like being crooks. I mean, that's another issue. And here's one I found years ago. I went through colleges to see their vulnerabilities, and I found a bunch of colleges infected by pharmaceutical redirectors, which are very common. And I didn't understand them very well at the time. I understand them a lot better now. But I notified the colleges, and this was one of my early adventures in white hatting, discovering what any white hat will tell you If you tell people about their problems, they simply do not care. The result is 2% of them will fix the problem, and 0.1% of them will attack you and try to sue you and put you in jail, and the others will just ignore you. It is an extremely unproductive activity to bother telling people about their problems. However, it's useful for me because I can then turn them into homework. Anyway, so here's the problem. Users put in arbitrary input and parameters, cookies, headers, and a lot of developers do not understand the security consequences of what they do. For example, they write JavaScript to validate things, and it's running on the client side in the user's browser where they can turn it off, and the developer doesn't understand that and thinks that there's been a security control preventing malicious input there. There are many things that happen like that. So you can change the price of an item and get a price item for cheap. You can exploit parameters, inject things like SQL injection, and even if you have properly encrypted transmissions like HTTPS, it won't stop any of these attacks. It will directly deliver the malicious payload to the server. Yeah.
Have you ever been able to do that in Amazon?
Not Amazon, no. Amazon is really quite secure. There are a few companies that are actually good. Amazon is good. I found a questionable practice at Amazon, but I wasn't. Amazon has a lot of layers of defenses, as they ought to. I mean, most of the web is actually running in Amazon. They're pretty smart. There's a few companies that are pretty smart. By the way, Microsoft is pretty smart too these days. They didn't used to be, but they got humiliated madly until they really improved their security. But a lot of other companies are still misleading. Let's take a look. I think it's Wednesday, but it's a good question. I don't know myself. Okay, mobile apps is, yeah, Wednesday. So feel free. And by the way, of course, as you probably know, all these are available online if you don't want to come to the real class. They're all going on YouTube and such and being live streamed. Anyway, so people often don't, it's easy to make a website and make it look good, and then you feel like you've done a good job, but you don't understand how vulnerable you've made it often. And it is really quite difficult. I mean, developers are working hard to make it pretty, to make it fast, to serve a lot of customers, to get rid of the bugs that prevent customers from buying things. And then they say, you're supposed to understand security too, and it's really kind of impossible, typically, for them to understand security too. What Dan Kaminsky, who is one of the thought leaders in this business, has said is you really ought to stop trying to tell developers to learn security because it's kind of impractical. What you ought to do is give them a development platform that is more secure. Like build whatever you need into something like Visual Studio. So whatever they make with that platform is secure. That's what Microsoft did. Microsoft used to have an appallingly insecure set of products around the time of 2000 and so. Their product was just ridiculously vulnerable. And the way they patched it was by modifying C and putting custom C libraries so their developers would not have the most dangerous methods. They were more safe. And that was a big part of how they improved their security. So there's a lot to be said for that. Anyway, so here's the security perimeter. We have things like firewalls and bastion hosts are the things that take data from an untrusted source like the internet and then supposedly scrub it before moving it forward. And but now customers are sending in data all over the place, and your web app has many components from many other people on it. For example, ads on your website that come from third-party sources that you probably can't really trust. So it's a big issue. You're trusting a lot of people. A few years ago, BART, during the time of like 2011, 2012, when there was all the Occupy Wall Street and the anonymous protests and everything, BART had a bunch of people protest BART and flood the BART station, so they turned off the cell phone repeater inside the BART station so people could not get on the internet from on BART to try to stop them from massing. And so in response, people decided to hack BART to punish them, and they couldn't hack BART. They hacked a third-party company called MyBART that had some of BART customers' credit card numbers and dumped it. So the result was BART was humiliated by losing customer data, but they didn't get hacked. And this is a huge problem of sprawl. If you want to secure something, the first thing is what assets do you have? And if you just ask a company, how many copies are there of the important data and where are they typically cannot answer that question. It's on this server, it's on Amazon, it's on people's cell phones, it's in their Dropbox, it's on a bunch of USB sticks, it's all over the place. And they say, well, first you're going to have to like control how many copies of that data there are before we can even pretend that you're securing it. And that is not easy. Anyway, so that's the, and the only thing people often hack email is often the single gateway to all your other activities. Anyway, things are getting better in some ways. For example, WordPress used to be just ridiculous. ridiculously dangerous, like Microsoft operating systems and Microsoft Office, and all of them got hacked enough times that it humiliated them into improving their game, and they got that. So some things are getting better. The operating system, Windows has gotten much better. Anyway, so I got a few Kahoot questions about that.
So how's PayPal doing?
I haven't tested PayPal. I think they're pretty good though, but I don't really know. It's a good question. I've tried various companies, but I don't think I've tried PayPal. But I think PayPal does in fact have a bug bounty program, which is a very good sign. That means they actually get some degree of reports and maybe do something about it. Now let's see if I put this in my favorites, which I intended to do, but we'll see. Here's my favorites. Oh, look at that. Something worked. Okay. So here's the first set of Kahoots. And I should bring back the sound then. All right. And I will put something up on the screen momentarily. There we go. All right. So these are worth extra credit if you get the most right. If you haven't done these before, I see some new faces. Most of you, I think, know my system, but anyway. It's random. I've seen it as short as 5. All right. These are just review questions. It's optional, but it's worth extra credit. And it tends to decrease the number of people falling asleep, or so I imagine. So let's, we're going to test dating apps. All right. There was a Trump dating app that was famously vulnerable, so I'm testing other dating apps. So far, it's pretty annoying. You have to answer a whole bunch of stupid questions before it lets you see if they're vulnerable. Anyway, let's save this somewhere. All right, this is going to be 129S, Kahoot. And it is January 14, 19. Whoa. All right, good. I'm ready to record winners.
You haven't picked on Apple today, right?
Well, Apple, I think, is also pretty secure. Like Amazon, I would be surprised to find a serious problem at Apple or Amazon, or for that matter, Microsoft. Those guys have been hurt enough that they've really hired a security team. You know, when Twitter was out, it was like 5 years before they even had one security professional. So, you know, there's people that haven't got, but those people have learned the hard way that you really have to have a security team and a chain of updates and all that jazz. Anyway. Oh, they're what?
Like somebody asked for their data that Amazon helped, and Amazon sent them recordings from Amazon.
Oh yeah, well there's certainly going to be mistakes of all sorts. Yeah, but you know, I mean, everybody will make mistakes, but I don't think you're going to find like a SQL injection main shopping site, something like that. Yeah. Anyway, so I'll give it a few more seconds and then we'll go. Oh, there's still some people coming. Okay. All right, let's do it. Okay, what makes Web 2 different than the early web? That might be easier. All right, user-submitted content, that's the new thing, which is quite more dangerous, but of course it makes it a lot more fun. All right, what does SSL stop? All right, it stops man-in-the-middle attacks. That is the point of it. You have a certificate that identifies the server, and if somebody in the middle tries to impersonate the server, your browser will detect it and pop up a warning if SSL is implemented correctly, which it frequently is not. All right, what's the most common vulnerability? cross-site scripting, almost most websites have it. If you wanted to be pedantic, you could claim they have meltdown in the sense that all modern hardware is vulnerable to meltdown, but there are mitigations, depending if you're being exploited in most cases. Cross-site scripting, though, is routinely all over the place, and people usually don't even bother fixing it because they don't take it seriously. Because cross-site scripting does not directly let someone take over your server. It just lets users hurt each other, and most companies have regarded that as not their problem. Anyway, what's the most important defense method? Most important thing is update. This is an interesting question. They did this survey about a year ago. If you ask average non-security professionals, they think antivirus is their strongest defense. It's not even in the top 10 of professionals, which is correct because it's useless almost. But updates are your number one defense. There's an endless chain of vulnerabilities, and if you patch them, then you fix them before the bad guys are good at attacking them. That's your strongest defense. Anyway, let me put a record the winners. Okay, so it's Chris Clark, looks like a real name, and MU will have to tell me who they are, and AG Levi looks like a real name, Levy. All right, so Moo will have to tell me who they are if they want to get points. Very good, okay, Michael, right?
Correct.
Okay, oh yeah, that's the real name, so good, okay, fair enough, I think I remember that. I'll put it here, so I'm not sure I can remember anything. There, that'll do, good, all right, so let's go back to the slides a bit, and then I'm going to demonstrate stuff. I may not finish chapter 2 tonight, we'll see. All right, so we'll talk about defense mechanisms. So you want to limit what users can do, and you want to scrub user input to try to do malicious stuff. So the idea here is to frustrate attackers and to have some degree of administrative monitoring, which I should mention on Saturday afternoons this semester, which we did it last semester a bit, and this is going to be practicing these activities, and it's mostly going to be Splunk. We did a couple of early versions of it last semester, and I found a way to improve it. So I'm just going to mention this. 124, which Elizabeth Biddlecombe is going to teach, I put it here in the schedule because I think it's primarily going to interest these people. See, these days have red versus blue. It's not every week that we're going to have. And it's worth extra credit in any of my classes. You show up here and you'll be doing attack defense. And you'll have scripts on both sides. And what you'll be doing is detecting the attacks with Splunk and hardening machines to protect them. So, and this, we did a few prototypes last semester to get it going. This semester, I want to polish it up. And by the end of the semester, I'm going to have real competitions with other colleges, team against team. Many colleges are interested, and I'm trying to make our own event here. It is supposed to be much easier, much smaller in scope, and faster than big complicated contests like CCDC, which we also participate in, but it's a big, famous national event. It's very difficult. It's very big, it's very complicated. This is a smaller thing like a homework assignment that really covers just one topic, only takes an hour or two, is not supposed to be as all comprehensive. Anyway, so I'll mention that. What's that?
Did they crash twice?
Oh, red version.
Events, right?
CCDC crashed many times, yes, because they have a really huge event. They have like 20 colleges competing, 10 machines for each one. It's a huge event. This is much simpler. You have one server or two. You have two students defending it and two students attacking it. A small, simple thing, easier to control. Much more to prepare for. So anyway, I'll talk more about that as we go ahead, but we'll be detecting attacks and seeing them. And that's what's going on here with this administrative monitoring. You typically do that with Splunk, which I'm also teaching a class in this semester so you can get your Splunk certification, which I highly recommend. Splunk is what people use to detect attacks, and it's very much worth knowing. Anyway, you need to authenticate people to know who they are. You need to somehow have a session management system so you remember who they are as they progress through the app. And then you need to have access control that actually makes sure that they are the right person before you let them do something, like let them in as an administrator and let them download personally identifiable data. All these have to be implemented correctly, and they are frequently implemented incorrectly so people can do what they shouldn't be able to do. Like that game app I mentioned earlier, where you could connect and download PII even though you were not really the administrator. If any of these things don't work right, those attacks become possible. Username and password is the cheapest and therefore the most common. It is the least secure. People hack into passwords all the time. It is ridiculously easy to do. If you actually chose something like a 12-character random password, it would really be strong, but the people don't. People choose passwords as the name of their dog plus a 1, and then they've used the same password on bunches of sites, and everybody gets hacked right and left. So before long, it's in a public box, and then people can get in. So there are many ways to do it. Use two-factor authentication, a password plus an SMS message, or better, a password plus a USB key or a local app on your phone. Client certificates are better, but there are a lot of other things that happen. People are self-registering, they're doing password recovery when they forget their password, and all those are often easy ways for guys to get in. There's really a fundamental problem here, because if you have a service that services a lot of people, if you have to have security, people are going to forget their password and get locked out. So what do? If you make them actually go in person and talk to the administrator and show an ID, that might be nice, but that would cost you a lot of money. So people are usually not willing to pay for that. So they have some kind of simple password recovery system, and that means the bad guys can get in. It's a tough job. And if you want to have good security, it's expensive. That is just a fundamental problem. And the same thing is true of the real world. Like in this room, the door's open, you can just walk in, anybody could wander in. We do get weird people wandering in. There's no great physical security here. And that's because that's why our tuition is low, like 0. But anyway, that's what you get. Anyway, so you log in like this, you put in a name, and then you're going to have rules here, like only 6 characters long and must have letters and numbers, but no spaces. Many people have stupid rules like this. Won't let you use special characters, won't let you use very long passwords. All of these are very stupid. You should let people use special characters and be as long as they want, but they often don't. So people typically have predictable usernames, passwords that are easy to guess. Yeah.
Is there a good reason? Because I see that restriction on, does that have to do with the limitation database?
Well, this is a very good reason when they limit the length of a password. Yes, that means they are idiots. It means they are storing the password in the database, and you should never do that. You should store a hash in the database. So you should be able to have the password be 300 characters long, and it doesn't matter at all, because I only use it to calculate a hash value, and I store the hash value. If they actually have a password length limitation, that means they have no idea what they're doing, and they're storing the password in plain text. Or they do not understand what they're doing, and they have somehow written a web that has a limitation. But if many people do store passwords in plain text, like Yahoo used to do this, and I think they might still do because it is leaked out. People on the Yahoo help desk tell me, I had students tell me this, you can call Yahoo and say, I forgot my password. And then you can say, oh, I remember it was like something like elephant or frog and then like 42. And I say, oh, here it is. They can see it and answer your question. So that is very wrong. They should not have your password at all. All they should have is a meaningless hash, which can be used to recognize the password when you enter it, but they shouldn't be storing anything that can be reversed into your password. That's many people still do not understand this though. They store the password in plain text in a database, and then they get stolen right and left. Anyway, then there's session management. There has to be some way to remember who you are. HTTP itself is sessionless. You get a request, you hand out the page. When you get another request, HTTP provides no mechanism to remember if this is the same person or a different person, because it wasn't designed for that. So Netscape added this optional thing called a cookie, which is added to the request, which you can use to identify people, and that's what's typically used. So the cookie records who you are, but cookies are often generated in unwise ways, so they can be predicted or guessed or stolen and reused, which we'll do quite a bit of. So that token is a problem, and we'll see. There are unfortunately a dozen different systems for handling these tokens, and they each have their own flaws. Then there's access control. Once someone is in, you have to decide if they're allowed to do something or not. This means you'd actually have to have permissions on folders and files and activities, and many people can't be bothered, so they just put a doorway and they assume if you find the page, you're allowed to be in there, which is easier to program, but easier to hack into also. That's insecure direct object access. Anybody can use it if they can find it. It's the equivalent of hiding a key under the mat. There's no actual protection. You just hope that the bad guy won't find it. The input validation is the most common system. Must have 4 letters, must provide an address, and so on. This is the main defense that people use all over the place. It has a lot of problems, but it is a simple line of defense. So people may be putting in text, form fields, things like user agent and parameters. All these things are important for the functionality of the app, but they might contain control characters or commands that run at the other end. So what's typically done is blacklisting. You try to have a filter that removes malicious input. The problem is this is just a challenge to the ingenuity of the attacker. Can they find a way to submit input which does not match anything on your blacklist but still causes harm? Like if you're doing SQL injection, you have to usually inject select. So if select is blocked, you could just try making capital and small case letters. You could try using different strings here. You could put a comment in the middle of it to break it up so it doesn't see select from, it sees other things. So any of these things might fool the injection system. Here's a cute one. You can put in a null character, which may terminate the string at the engine that is looking for bad characters, but it may not terminate the string at the engine that actually uses it. This is quite common because, again, you typically have something like a web application firewall, which is not the real application, which does some attempt to sanitize it and then passes it on to another system, which is running a different operating system, a different set of code. So it is entirely possible that your sanitization routine is not identical to the actual parsing routine used by the server behind it. So what's much safer is accept known good. You don't try to enumerate all the evil in the world. Instead, you enumerate all the good stuff and only accept stuff that is known to be good. This is a lot safer if you can do it. All right. And then there's sanitization, is attempting to remove dangerous characters and things. HTML encoding changes space into %20 and so on. The problem is it's difficult if you have multiple servers. So this is safe data handling. You can actually write code that is less likely to misunderstand the input. Like you can use parameterized queries because they take data and put it in parameters so that data cannot be misunderstood as commands in a separate data object. So no character put in the data can ever cause it to be misunderstood and interpreted as a command. This is very good, and it's what everybody should do. But if you take a class, they won't teach you this, and you'll typically learn the old easy way because it takes a few more lines of code to do it this way. But you can write more secure code, and then it doesn't matter if the other people in the system make a mistake and the attacker is able to inject dangerous characters, they won't have the usual effect there. All right. Anyway, I think that may be enough of this for a while. I'm going to just record that we got to 39. And then I just want to demonstrate the first project here because it's good, clean fun. Let me just find some place I can put this. Come on. Okay.
So how do you feel about security questions?
You mean proofing questions?
Yeah.
Oh yeah, those things when you have your name, you want your mother's maiden name or something. Those things are very weak. They're the thing where you have to log in, you also have to give your mother's maiden name or your birthday or something. That's proofing, is what that's called. And it's famously very weak, like a password. That's how people get hacked a lot, because I can just guess or look up the answers to those questions and then reset your password. So, I mean, by the way, if you want to make your life safe, what experts say is always lie. Don't put your real birthplace, your real mother's maiden name, have some lie that only you know. That will really slow down social engineers that go look up your real birthplace and try putting it in. Of course, I don't know how you're going to remember it, but that's like those long passwords. If your password was really like 12 random characters, it would be secure, but how would you remember it? And the answer, by the way, is get a password manager. We should all be using password managers so you have a different password everywhere. It took me a while to switch to it. Now I feel a lot better. And as a matter of fact, I've been a target for years, and my emails never, my city college grading system. Yes, Yale got hacked at DEF CON years ago, but not since then. And nobody's ever hacked the city college grade system, the grades or anything. Any of my systems, even though I've been a target, have not been hacked. Using a password manager is a very good policy. I highly recommend it. It takes a little bit of time to get used to it, then get used to it. I don't know, there's RoboForm, LastPass, a bunch of them. As far as I know, they're all about the same. But the most important thing about them is you really have a different password for every site. And that is huge because they're losing it at the other end. Anyway, let me just show you the first couple projects. You can start doing this stuff. So down here are some projects. That's the wrong class. Okay. 129S. There. That's good. All right. So let's start with command injection. This is the simplest web vulnerability. And I set up a system here which is like your router. So the first thing is you should learn a little bit of Linux. If you don't know any Linux, there's a Linux course you can take here, but you don't need a whole course worth of Linux to do what we're doing here. Just a few simple commands are enough. And so let me demonstrate these. And you don't even need to have Linux installed anywhere. You can use this web version of Linux if you like. Maybe I'll use it here. This is because of containers. Because of containers, it is so cheap to run a container that you can have a server that runs 100 containers. So many people now have free servers you can use because it's really very cheap to do. And that's what this is. This is running some version of Linux right here in the browser, and I have my own instance of Linux. Let me see if I can make it big. Maybe not. Okay, I'm going to not use that. I'm going to use my local machine so I can make it bigger. But you can do it all in there if you don't happen to have a Linux machine available. Now I have a Mac, so my Mac is running Unix, which is good enough. All right, so here's my Unix command line. And let me just demonstrate a few simple commands. If you don't know any Unix command line, you can learn enough here. The simplest command is date. It just prints today's date. Just show you how, so that's harmless. ls shows me the files and folders in the current directory. So I've got various things like desktop and documents and so on. pwd tells me where I am. Print working directory. This is the difficult thing about the command line. If you use the mouse and the GUI, you see a list of folders. You double click on it to open the folder and you can see where you are. In the command line, it's not obvious where you are. So you have to keep track of where you are. I'm in this directory, users Sam Bowne. Now, if I change directory, I can cd someplace, like I can go to /temp. This is where hackers often go. The temp folder is full of things generated for only temporary use, and when the server restarts, they all get erased, but everybody has write permissions to the temp folder. So when you are doing something like stealing data or injecting a script and you want to run it, if you put it in the temp folder, you will almost always have permission to write there, which is very handy. So it's a common place hackers go. So I can go to the temp folder and do ls and see there's a couple of things in there generated by the system. So now you can move to another place. If I do cd alone, it takes me to my home directory, which is determined by who I'm logged in as, but I can go anywhere I want. / is the root of the whole system in Linux. If you do ls, you'll see things, they're always the same. Things like ets, sbin, and temp, user, and var are things you always see here, a standard Linux file system, and temp is here. Now, you can echo things. If I echo hello, it prints hello on a screen. This is pretty boring, but it's a way to create text files, which is what you're going to have to do to succeed in this project. And the last thing is injection, output redirection. So if I take date, that puts the date on the screen. But if I do date greater than foo, it doesn't put the date on the screen. What it does is create a file called foo and put it in there. If I do ls, I now have a file called foo. If I do ls space -l, for long form, it shows me more information about the files. And now I can see that the file called foo is 29 bytes long. Yeah, because it's the date. This is how big it is. And there's other information here like who owns it and permissions, the time it was changed. If I want to see what's in that file, I do cat. Cat will print what's in a file. So cat foo shows me the date is in that file. Now, if I echo hello into foo, and now I do ls -l, foo is now only 6 bytes long. So if I cat foo again, I've lost the date and replaced it by hello. If I wanted to have 2 lines of stuff, I'd have to use 2 greater than foo. This will add data to foo without erasing what was already there. So now if I cat foo, I've got hello and the date. So that's very simple text and file manipulation on Linux. And I think that's all you need for this, because what we're going to do is we're going to deface the server. So now here is, so the first thing is to create a file with certain things in it using these techniques just to show you can do it. And email in an image of this just to show that you can do some basic Linux. And then we're going to attack this point. So we'll go to one of my servers. I have a bunch of cloud servers at DigitalOcean that are vulnerable. They're not the ones that host my website or anything important because they keep on getting hacked and going down, of course. So That's what they're there for. So if you try to do your homework, this server might be down. If so, let me know. I have a tracker, uptime here, and you can see that my servers have been up for a week, and that's because school is out of session. Nobody's hacking my servers. By next week, a bunch of these should have some downtime, as everybody keeps hacking. Right now, nobody's been hacking, but that should change. Anyway, so, and therefore, there are, of course, a bunch of ways to cheat on this, because once you hack the server, you can find the answers on there and stuff. Various people do that. So be aware, if you cheat on them, you may not get the intended benefit from the projects, but this is, the whole point of hacking is pretty much cheating. Chat messages are, how effective is using Cloudflare? Cloudflare is quite effective to stop denial of service attacks. It is not very effective at stopping other kinds of more advanced attacks. At least the last time I heard a report on it, a few years ago, they said Cloudflare's web application firewall was not much better than, say, mod security. I haven't seen an objective test, but I don't think it is very good, better than most web application firewalls. And once you mute people in Zoom, oh good, thank you for telling me. Yes, this is a problem. People keep making noise in Zoom. Okay, yeah, remind me of that. I will try and remember that. That is a problem. Anyway, so let's hack this website, which is here. Okay, here's a form. The point of this is a ping form. This is a very common vulnerability you'll see in a router. Now, I used to be able to ping things like Google from here, but somebody exploited my server and used it to attack my other servers with a ping, so I blocked that. So now you can only ping localhost. But it'll do for what we're doing here. So if you ping 127.0.0.1, it will send some pings and show you 64 bytes from. Now, this would be fine. The problem is the web application developer, which is me, chose to write a really sleazy script. Instead of figuring out how to actually perform a ping from inside PHP, which is what this is written in, they just created a command line where they take the word ping and then follow it by the address that you put in the form. So that means if you understand this, you can add another command here, like date. So it will ping this and then perform date, because you can put multiple commands on the same line in Unix by separating them with a semicolon. So now it does the ping, and then it prints out the date. What this means is I was supposed to just be able to test the network with an IP address, but now I can execute arbitrary commands here. I now control this server. This is called command injection, and it is very simple, very often exploited, and it happens quite often. So I can now, if I want to know what my privileges are, I can do who am I? To see who I am, I can do, say, ls-l of /temp. And see what's in the temp folder. And I can just have as many commands as I like there. And so here I am www.data, which means I'm running as the Apache user, which is typically who you're running as when you connect to a web server. And here's the files in the temp folder. So that's the, I now can execute commands on the server. And so here's your challenge, put your name in that file. And when you do, you'll appear on the winners board. There is a script running to take names out of that file and put them on the winners board. So there should be some, yep, here's some people that have won in the past. Maybe I'll clean off these old ones. But anyway, that's the ping command injection. So that's a simple one. Now, I would recommend that you don't stop there, but do the extra credit. Extra credit is good for you. So that's simple command injection. Here's a couple other command injections down here in project 1X. All right. And that's here. I think I'll just demonstrate the first one of these for tonight and the next one next time. The buffer overflow is a good clean one. So here I've got a small variation forward. Here is the source code of this one. It's going to take a buffer up here, which has 200 characters, and it's going to take your name and read into that, and then it's going to have, call this BO function with two parameters. The first one is the name you put in, and the second one is a Unix command, uname -a. Uname -a is a harmless Unix command that just gives me the version of Unix that's running on the server. So if you put in a reasonable name, it's going to go down to a subroutine and copy those parameters into a variable that's only 40 characters long instead of 200. So if the name is short, less than 40, it will fit, and you'll just print out, say, goodbye name, and then execute that command. So let me run this. If I put in a name like Sam, and then execute, it says name is Sam, executing this command and there. That's fine. If your name is short, everything works as intended. This is very common, of course. Most people won't deploy a product if it doesn't pass basic unit tests that it does what's expected under normal conditions, but they often don't test it enough to discover that there are other ways to exploit it. So if you put in a name that's 42 characters long, like that one, then the name is 40 characters followed by ls, and now it executes the command, and the command that should have been uname -a is now ls, because it ran over one variable and leaked into the next variable. This is not the most common kind of buffer overflow, but it is one of the most dangerous because it's very hard to fix. There are a whole bunch of buffer overflow defenses. We go through it in the exploit development class, which I taught last semester, although not this semester, and talk about this. There are a lot of defenses, like canaries and buffer overflow, but they can't stop this kind of attack. This kind of attack is very hard to detect and stop. Anyway, so now you can inject code again. I can do ls, date, who am I? Who am I? On the server, and it will do an ls, and then it will do the date, and then who am I? So again, you can execute commands. The problem with this one is you cannot inject a space easily. So you'll have some difficulty getting a long list and so on. But anyway, you can again get yourself on the Hall of Fame here and give it a shot. Yeah.
Does that also have read and write?
Yes, it has read and write privileges of that user. The www data user doesn't have the right to write very many places, but they can write into the temp folder. That's by design. You know, they designed Apache. Really old products like old versions of IIS would run as root, run as administrator. This is, of course, a really bad idea. And everybody found out, like getting hacked, this is a bad idea. So now most modern web servers run with lowered privileges, so that when a web designer makes a sloppy page like this, they don't compromise the whole server as much. And I know IIS, Microsoft's product, in version 7, everybody used the same identity. And in version 7.5, each website has a different identity. So when people write one sleazy page, they don't get the other people on the same host hacked so easily. And that's the thing. I see Microsoft used to be a laughingstock of the world in security, and they're more and more a good example. Because they have done everything wrong and gotten hurt, they have learned a whole lot of good security lessons. And other companies like Apple and Google are miles behind catching up, reproducing all of Microsoft's stupid mistakes. Like you see, take the web application hackers class, you'll see Google single-handedly repeat Microsoft's reputation. You know, for years people found Windows is vulnerable, and they said Microsoft is a pack of idiots. And Microsoft said, no, we're not a pack of idiots, we're just popular. So we have a really big problem. A lot of people are using it, so we're a big target. We're not any stupider than anybody else. And Google proved this. They proved that if you make Linux crappy enough, it's just as bad as Windows ever was, which is what Android is. Android is appalling, and we'll be hacking Android right and left. Android is like the way Windows was in the days of Windows 98, and they're trying hard to improve it. But Android still has not solved the problem of having updates to fix security problems. Something that Microsoft, I think, started 10 years ago. Everybody seems to make the same series of mistakes and then eventually put in the same fixes. But Android should have some kind of automatic update. They should have some kind of security patch cycle that you have to get, or you're very strongly encouraged to get. And they're suffering because they didn't. Apple suffered the same way because they didn't have updates enough. And everybody has to get hurt the same way before they realize they have to put in the same thing Microsoft has. Yeah.
Is iOS difficult to hack?
Yes, iOS is much more secure because it is very limited. I mean, the whole point of iOS, you cannot put it on an app from an untrusted source. You have to get it from the Apple Store, and they actually police the store and don't let you put malware in the store. That turns out to be extremely effective. So iOS, if you have it on iPhone, it is an almost perfect computing platform. It is very hard for anybody to infect it or hack you on an iPhone. It is also quite limited. You cannot write your own software and run it. You can't download arbitrary applications. That's the point. It's sort of like being a little kid where you're in your backyard and your parents will only let certain people back there. Nobody else can get in. Your parents are watching over you. As long as you play by the rules, you're really a whole lot safer than the Android kids playing in traffic. But of course, Android has freedom. You can write your own app. You can jailbreak the thing. You can put on a custom kernel, do anything you want. But with that freedom means all the hackers can do all that to you too. So that's the Apple has always been the walled garden of not much freedom, where you're trapped in their little world, and much safer as a result. Yeah. Windows 10 is that's a very difficult question. The question is Windows 7 better than Windows 10? From a security point of view, I would like to say Windows 10 is better because Microsoft is constantly adding more defenses, but Windows 10 has some particular problems caused by Meltdown Inspector. A year ago, Meltdown Inspector came out, and Microsoft has been like the Keystone cops falling over their own feet for a year trying to patch it. And their patches have lowered the security, caused disasters, caused performance problems. It is kind of a mess. So right now, I'm not sure. In general, the latest version of Windows is always more secure. Windows 10 is right now a particular problem because they force you to get the updates, and a lot of the updates are broken and cause trouble. So it is very unclear. And some highly respected experts like Wendy Leonard have said you should not put any update since last year on your Windows servers anymore because the updates are so terrible. So that is a pretty bad situation. But normally, the safest thing in the world of Windows is to always have the latest version and always put on the patches. And presumably, at some point, Microsoft has been apologizing and promising they're going to fix their update process. Presumably, they will get their act together and restore us to the condition where the best thing you can do is just have automatic updates on your Windows. But for the last year, that has unfortunately not been true. And Microsoft is aware of that. It's a huge scandal, and they're promising they're going to do something about it, although I haven't had much luck so far. Any other questions? Well, we'll come back here and do it. Yeah, go ahead. Yeah.
The meeting, do I supplement that based on project, like project 1 is chapter 1?
Oh, the projects are not closely tied to the reading, only approximately. So there's you read and take a quiz before class, and that tests your comprehension of what's in the book. The projects approximately cover the same material, but it's not a one-to-one correlation at all. The projects are really whatever I could easily write and get working to demonstrate these things. That's why if you actually pay the author like $35, he has a special website that's project particularly tied to each chapter. And I've had some students do that, and they like it. This is my attempt to write my own version of the same thing. But I'm not as thorough as his. So yeah, the projects are good though, so you practice these activities. Any other questions? Well, I guess that's it. I'm going to stop the share, and we'll finish this chapter next time. And I'll stick around for a while and go take a look at the lab and see what's happening, but I imagine